Thank you for joining me to discuss the ins and outs of each of the science and engineering practices. My name is Eddie Walsh, and I want to start us off by having us consider an ecological phenomenon you could explore with your students if you are looking for phenomena to implement in your classroom.
Caribou is where I started my career with the Idaho Department of Fish and Game. I had only been working a few months for the agency when I became a temporary on the Selkirk Caribou project back in 1983. When I started on the Caribou project, I was working for Mike Scott, who was the project leader, and it was basically a study on the ecology of the animal. So we had radio collars on those animals, and we followed them year-round by air, by ground, on snowshoe, by foot, up the mountains and down the mountains, to really look at how many we had, how reproductive they were, what kind of habitats they used, anything we could learn about the ecology in order to try to make some management decisions. And what we found was basically we had a good understanding of what they were doing. We also had a good understanding that they were barely hanging on. And what we all, as a caribou committee, decided was needed was a caribou transplant from British Columbia to northern Idaho to help supplement this in hopes of trying to get these animals back on their feet. Well, I think our first transplant was in 1987, and I think we brought in 28 animals from Anaheim Lake in the Itches and Ilgachas Mountains north of Anaheim Lake in British Columbia. Unfortunately, that was the first transplant. That we did two more after that. Brought in a total of, I can't exactly remember the numbers, it was so long ago, but probably slightly near 70 animals total. And hope that would work, but as we know now, it wasn't enough.
So when you heard that on both sides of the border now, that ecosystem that you had spent 8 years working in has changed so much that they pulled the last two caribou out of the ecosystem, what did this feel like?
Yeah, it's an interesting question. You know, these caribou are native to Idaho. So this is a native species that we've lost. And it's not lost because of lack of trying. I think most of all what concerns me is it kind of happened with a whimper. Especially to me after all these years and knowing all the work that people have done, that many of the problems that these animals face and that many other species face are bigger than just the efforts that, let's say, the State Fish and Wildlife Agency can handle. And we have to look and do and act in much different and bigger ways, I think, to be effective and to do the wildlife management that we're going to need to do. And I think the caribou is a classic example of something that shows us that in a mere 30 or 35 years, even though we could say, well, it was peripheral range and they were barely hanging on, 30 or 35 years from now, what species are we going to be saying that about in Idaho again?
A quick and easy way to get students thinking about what they just saw would be to have them document what they notice and what they wonder about the video they just watched. After some quiet time to work independently, students can share out their notices and wonders in their pairings or groups before collaborating and selecting their top notices and wonders. As we lean into the science and engineering practice of analyzing and interpreting data, this would be a good opportunity to ask students to consider what they noticed and wondered about the phenomenon that might inform how federal and state agencies collect and manage data surrounding woodland caribou populations. You could even have students examine raw or visualized data to produce more notices and wonders for their inquiry. If a student or group of students already began examining or questioning data around caribou populations, be sure you use that student-generated observation to lead into this next part. After having students consider the phenomenon generally, you can then have students reflect and consider what they notice and wonder about the video they just watched, paying special attention to the data analysis conducted by wildlife management agencies. The data students gather from their investigations in a traditional science classroom is generally tailored to spell out very obvious conclusions, and those conclusions are often accompanied by a teacher telling them how to analyze their data at every step along the way. This often removes all of the scientific practices from a learning experience surrounding data analysis and leaves students without the repeated practice needed to develop science skills independently. Only with frequent observation, analysis, and interpretation of data can students develop personal mastery in the data analysis process. I want to go ahead and fully introduce myself. My name is Eddie Walsh, and I'm the Region 6 Instructional Science Coach working with the Idaho Department of Education. I am based out of Idaho Falls, but myself and the other Idaho science coaches are happy to meet you wherever you are in your science education journey. Our sole focus is to help teachers plan, teach, and assess around the Idaho Content Standards for Science. I wanted to take this opportunity to focus on how we can approach the science and engineering practice of analyzing and interpreting data. If you have further questions about how the Idaho Science Coaches can help you with your teaching goals, feel free to reach me at my email or visit our Idaho Science Coach website via the QR code or Idaho Department of Education website. When the National Academies of Science, Engineering, and Medicine developed the 3 dimensions of the framework for K-12 science education in 2011, the science and engineering practices were recognized as perhaps the largest shift educators would need to address to engage students in the immersive experience that is science. Utilizing data to define and support conclusions requires students to make sense of the quantitative and qualitative factors embedded in a phenomenon. Asking students to analyze and interpret data means providing students the opportunity to organize raw data from an investigation and make sense of the micro and macro trends they see in that data. Allow students to come to their own conclusions while also helping them to see the disciplinary ideas included in the standards. Providing students the opportunity to practice data analysis gives students a greater sense of how scientists collect data and also how scientists prepare data to be shared with a larger audience. As engineers, students can use data to determine which strategies are most efficient and useful when trying to design solutions to problems. I would make it my recommendation to you right now. If you want to get your students to analyze and interpret data independently, do it as often as you can. While students may initially find data analysis to be messy and time-consuming, with frequency and practice, students will be able to make sense of any data set. Frequency and variety in data analysis will prepare students for the spectrum of critical analysis needed to make sense in the infinite opportunities presented by science. When bringing up science from the past, science teachers often gloss over all of the data scientists analyze and instead present final conclusions without much context or nuance. Showing students the data collected and analyzed by past scientists allows students the opportunity to see which data speaks to them and use this insight to inform their methods and conclusions. Showing students the way Joseph Henry collected and analyzed data from across the United States to forecast weather could demonstrate how the weather patterns from almost 200 years ago behave in a manner similar to those of today, but the technology has changed drastically. Flipping through the journals of primatologist Jane Goodall can demonstrate how qualitative observations can be used to identify patterns that may not be easily measured through quantitative methodologies. And looking at the methods of scientists like astrophysicist Neil deGrasse Tyson can show students how large shared data sets and technologies can be analyzed in a multitude of ways to present new and unique findings when a different perspective is implemented. As scientists, we individually can focus on different aspects of phenomena, and through that focus offer different interpretations based on the same observations. Analysis and interpretation of data offers every scientist an opportunity to place their stake in the frontier of scientific discovery. Integrating the science and engineering practice of analyzing and interpreting data needs to look differently at each step in the K-12 student experience. We, as teachers and administrators, recognize when one grade band or another doesn't provide students opportunities to advance in their analyzing skills, we limit student potential throughout their entire learning progression. Imagine the disconnect someone might experience where they provided a list of scientific conclusions to explain almost every aspect of their life, but they are never shown why or how those conclusions came to be. Imagine also the confusion someone might experience were they never shown how to connect the dots within a data set to define a scientific conclusion. The K-12 Skills Progression document on the Idaho Department of Education website breaks down the experiences students should be able to navigate to stay on track with their peers locally and nationally. This document provides teachers with starting points for imagining a range of student experiences that allow students to build competency in the range of skills associated with analyzing and interpreting data. When laid out this way, we can provide clearer feedback to students and scaffold more for students who can find data analysis to be difficult, or challenge students who may have shown early mastery in the science and engineering practice. It becomes important to remember students often do not master a standard in a single instance, so planning several opportunities for students to flex all of their data analysis skills within a grade band is critical for all students to stay on track in their science progression. If you are looking for data to bring to your classroom explaining the interdependence of species in an ecosystem, you may consider walking students through the work of Dr. Jen Cruz at Boise State University. Dr. Cruz examines a variety of animals in a bunch of different environments, but the data used to inform her conclusions tells a compelling story of the interactions between organisms in each location. For example, by counting the occurrence of poop pellets in different locations throughout the Southern Alps of New Zealand, Dr. Cruz was able to substantiate conclusions that promote the management of Himalayan tar populations in order to conserve grassland habitats in the region and decrease ecological stress brought on by the introduction of the Himalayan tar in 1904. Analysis of this data provides ecologists real-time feedback on the conservation efforts and allows scientists to consider strategies for engineering solutions. If you are looking for strategies to bring data analysis to the forefront of your teaching, I have a few materials you may consider if you feel this will be a rough start. Tuva is a data analytics hub with a range of data sets centered around a variety of science phenomena. The website guides students through each dataset to help students come to data-centered conclusions just as they would were they conducting their own data analysis with their own data. Students can analyze a set of variables against each other in the modules, which visualize data sets to give students a range of methods for interpreting their conclusions. Excel and Google Sheets may seem like old methods, but spreadsheets often underlie most data and analysis software scientists use today. Giving students practice and competency in Excel and Google Sheets will provide students with skills that will serve them beyond their science investigations as well. Finding datasets is a frequent challenge for teachers who are trying to place data in front of their students. Kaggle and Data Science for Everyone both have a broad range of datasets to analyze and curricular tools for implementation in the classroom. If you have your own datasets already, you may find Tinkerplots useful in helping students create visualizations of their data for interpretation and presentation. I would highly recommend teachers access the Foundation of Data Science for Students Grades K through 12, published by the National Academies. This is a free virtual resource that outlines a multitude of strategies teachers can adopt to make sure students meet their data analysis benchmarks. If making time for science and engineering practices seems difficult, consider going deeper into units centered around data analysis, and pull back on content-heavy instructional days with lectures and worksheets. Thank you for your time as we cover how data analysis can help students access authentic science learning opportunities. Hopefully the understandings and strategies outlined in this video make it less stressful to bring instruction around analyzing and interpreting data to your students. Please do not hesitate to reach out to me or anyone on the Idaho Science Coach team to clarify anything about the standards.